Have you ever, like, just picked up a simple rock?
Like a piece of quartz or
Yeah,
something.
exactly. A smooth piece of quartz from a riverbed, or just stared at a single drop of water hanging off a leaf, and you just wonder if there's some kind of hidden inner life trapped inside it.
Oh, wow. Yeah, like more than just dead matter.
Right. Because we're taught, from grade school to see the universe as this giant, incredibly complex, but ultimately dead machine.
Just atoms bumping into atoms in the dark.
Exactly. Just following these rigid mathematical laws. But what if the universe isn't just a collection of inert objects? What if it's, well, a living, breathing process of becoming?
That is a massive shift in perspective.
It really is. And that radical shift is what got a brilliant paleontologist completely banned from publishing his life's work by his own religious order back in the 1950s.
Yeah, it's a wild story.
So today, we are doing a deep dive into Pierre Teilhard de Chardin's forbidden masterpiece, The Phenomenon of Man. We're going to try to understand how dead dust became a living planet, and why that cold, mechanical view of the cosmos is, frankly, hopelessly incomplete.
It's so incomplete. And to really understand the magnitude of what we are unpacking here, we have to look at the man who actually wrote it.
Right, because he wasn't just some armchair philosopher.
No, not at all. He wasn't just sitting in a room theorizing about the cosmos. He was a highly trained, deeply respected paleontologist.
He was in the dirt.
Literally in the dirt. He did the gritty field work in China. He actually co-discovered the famous Peking man fossils in 1929.
That's a huge deal in evolutionary biology.
It's massive. So he deeply understood the hard, empirical science of evolution, the physical evidence buried in the ground. But simultaneously, he was an ordained Jesuit priest.
Talk about a crazy intersection of worlds.
Right. He lived his entire life right at the crossroads of two worlds that are usually seen as, like, bitterly opposed.
Rigorous empirical science on one hand,
Yeah, and deep, mystical, spiritual philosophy on the other.
and he didn't want to choose between them, right?
Exactly. He refused to. He sought to create this grand synthesis, a vision of humanity and the universe that honored both the cold, hard, scientific facts of evolution and the profound intuition that the universe is actually moving towards something.
But trying to marry those two worlds in the early 20th century, that's exactly what got him silenced.
It was incredibly dangerous for his career. His unorthodox theological positions, specifically his view that evolution was this ongoing spiritual process, were totally at odds with the strict Catholic doctrine of his time.
So his Jesuit superiors just outright forbade him from publishing his philosophical writings.
They shut him down completely. The Phenomenon of Man only saw the light of day and became this massive bestseller when it was posthumously published in France in 1955.
Wow, after he died.
Yeah. And his approach was entirely unique because he was attempting to create what he called hyperphysics.
Hyperphysics. Okay, let's unpack this. What makes it hyper?
Well, traditional physics tries to explain the universe by breaking it down into smaller and smaller dead parts.
You'd reduce everything to mechanics.
Exactly. But hyperphysics looks at the universe as an organic, unfolding whole. It takes the hard physics, but asks what those mechanics actually mean for the entire system.
That's a holistic view.
Very much so. And for our exploration today, we're going to tackle this as a tag team. I'll lay out the biological and physical mechanics he's describing, like the empirical science he relied on.
And I'll be here to push, prod, and poke at the profound philosophical implications of those mechanics. Because, if you've ever felt overwhelmed by the sheer coldness of modern science.
That creeping dread.
Yeah, that dread that we are just accidental, meaningless biological accidents on a rock hurtling through a dead void. If you felt that, this deep dive will give you a completely new lens to view your place in the cosmos.
It really bridges the gap.
It does. And the first step in building that bridge is tearing down our fundamental vocabulary. Teilhard argues that we actually have to abandon the entire concept of cosmology.
Which sounds counterintuitive, but the suffix ology implies the study of something static.
Like geology is the study of rocks.
Right. Topology is the study of shapes. You're cataloging things that just sit there and exist, but the universe is not a static thing to be cataloged.
It's an active, ongoing process.
Exactly. Therefore, we have to replace cosmology with cosmogenesis.
Cosmogenesis, the
Yep.
suffix genesis meaning birth, creation, or origin. A continuous process of becoming.
Yes, the universe as a massive, continuous process of genesis and evolution. It's not just a stage where evolution happens to take place.
The universe itself is the evolutionary process.
You nailed it. And to understand this cosmogenesis at its absolute root, we have to look at the elemental matter of the universe.
The building blocks.
Right. And Teilhard breaks this elemental matter down into three distinct phases: plurality, unity, and energy.
Okay, let's look at plurality first.
So with plurality, he's talking about the profoundly atomic character of the universe. And he doesn't just mean atoms in the modern chemical sense.
He means the fundamental granularity of reality.
Yes, the particulate nature of everything.
Like if you look at a raindrop or a grain of sand and you keep zooming in, you never hit a solid, smooth wall.
Never. You just hit more and more discrete particles.
We scale down to molecules, to atoms, to electrons, to quarks. The scaling down seems almost unlimited, right?
It really does. The deeper you go, the substratum of the tangible universe reveals itself to be this bewildering swarm of the infinitesimal.
It's like a state of unending disintegration as you go downward.
And modern particle physics has confirmed this beyond anything the ancient philosophers could have dreamed. But here is the paradox Teilhard introduces with the second phase of matter unity.
Okay, so plurality is the infinite dots. What is unity?
He calls it the totem and the quantum. The universe doesn't just contain things like a box contains marbles. It is woven from a single piece.
Wait, woven from a single piece?
Yeah. The more we split and pulverize matter artificially, the more insistently it proclaims its fundamental unity.
Okay, I have to push back here. If matter is just an infinite swarm of totally disconnected, infinitely small dots, which is plurality, how does it hold together?
It's a great question.
I mean, if I smash a rock into dust, I've proven it's breakable. I haven't proven it's unified. My hand doesn't just disperse into a cloud of quarks, but based on pure plurality, it kind of seems like it should.
Well, think about the particles themselves before we even get to macroscopic objects like your hand. When we isolate electrons or protons, they manifest a perfect identity of mass and behavior everywhere in the universe.
So an electron here is the same as an electron somewhere else.
Exactly. An electron in your coffee cup is practically indistinguishable from an electron in the Andromeda galaxy. They are astonishingly monotonous.
So the stuff of which all stuff is made is reducible to a single, unique kind of substance.
Right. But the unity goes much deeper than just looking identical. We cannot define any cosmic particle just by its physical dimensions. We have to define it by its radius of action.
Meaning like how far its physical influence extends outward into space?
Yes. Every particle has a gravitational pull, and many have electromagnetic fields. However narrowly the physical heart of an atom might be circumscribed.
Like the tiny nucleus in the electron cloud.
Yeah, the tiny core. Despite that, its realm of influence is technically coextensive with all of space.
Wait, all of space? Really?
Seriously. The gravitational pull of an atom in your hand literally extends to the edge of the observable universe.
That is mind-bending.
It gets unimaginably weak, of course, but it technically never hits absolute zero. Therefore, every single particle is intricately woven into the whole.
So you cannot move a single atom without technically shifting the gravitational web of the entire cosmos.
Exactly. It is a single, structurally unified system, a whole.
Wow. It's like looking at a pointillist painting, like Georges Seurat's A Sunday on Le Grand Jatte.
Oh, that's a perfect analogy.
Right, because you stand 1 inch away from the canvas, all you see is plurality. Chaotic individual dots of paint. Blue, yellow, red, none of them touching.
It's just a swarm of dots.
But then you step back 20 feet, and the plurality gives way to unity. Those totally disconnected dots suddenly form a woman holding an umbrella, a river, a dog. There is this mysterious unity from below that holds the entire image together.
Yes, beautifully put. So we have the dots, which is plurality. We have the interconnected picture, which is unity.
What about the third phase, energy?
Energy is the dynamic glue. It is the primordial flux, the actual capacity for interaction that allows the plurality to form the unity.
So it's the force driving it.
Exactly. It's the measure of what passes from one atom to another in the course of their transformations.
Okay, so traditional science measures the dots. It maps the structural system they form. It calculates the energy pulling them together.
Right, the standard physics approach.
But Teilhard argues this purely external measurement, this traditional physics, leaves a massive glaring hole in our understanding of the universe.
A gigantic hole, because everything we just described is studied entirely from the outside.
And if you only look at the outside of things, you eventually hit a brick wall when trying to explain the universe as a coherent, unbroken process.
You absolutely do. And that realization right there forms the bedrock of his entire philosophy. the concept of the without and the within.
The without and the within.
Yes. The without is everything we just discussed. The measurable external mechanical properties of matter, mass, velocity, charge.
The stuff you can put a number on.
Exactly. It's what you can see under an electron microscope or measure with a spectrometer. Science traditionally only studies the without.
It treats everything as objects.
Totally. A bacteriologist treats cultures of cells as mechanical laboratory reagents. Botanists often view plants as just complex chemical machines driven by sunlight and water.
Which, that mechanical view of the without works perfectly fine if you're building a bridge or calculating the trajectory of a rocket.
Sure, mechanics are great for mechanics.
But it fails completely. It just collapses in on itself when it gets to us, to human beings.
It hits a wall.
Because in humans, we have a direct, undeniable intuition of our own within. I am experiencing the world right now. I have consciousness.
You have an inner life.
Right. I have interiority. I have subjectivity. I'm not just a meat machine reacting blindly to stimuli. I am actually experiencing the stimuli.
But traditional cosmology looks at human consciousness and basically treats it as an anomaly.
A glitch in the system.
Yeah. The technical term in philosophy of mind is an epiphenomenon.
An epiphenomenon.
Right. It's treated as a random byproduct of complex brain chemistry. What's fascinating here is the analogy usually given. Think of the sound a steam whistle makes on a train.
With the whistle.
The sound of the whistle doesn't drive the train forward, right?
Mm-hmm.
The burning coal and the steam pressure do the actual work.
Right. The sound is just a side effect of the mechanics.
Exactly. For a long time, and honestly even today in many circles, science treats human consciousness exactly like that whistle, an aberrant function, a side effect of a massive neural network. Something to be ignored when calculating the fundamental physics of the universe because it just doesn't fit the neat mechanical models.
But this is where Teilhard calls out a massive logical fallacy in scientific thinking.
Yeah.
You cannot have a coherent universe if you treat its most profound feature as a literal magic trick.
You can't. It breaks the whole concept of cosmogenesis.
Right. If we accept that humans have consciousness, a within, and we accept that evolutionary biology is true, we have a major problem. Because evolution is gradual. It's a process.
It doesn't make leaps out of nowhere.
Exactly. You don't just put a bunch of dead, unfeeling carbon atoms in a cosmic blender, let it spin for a few billion years, and suddenly get a feeling, experiencing conscious being.
The math doesn't work.
If you say consciousness just magically popped into existence at the very end of the evolutionary line, you are abandoning science.
Yeah.
You are saying something came from absolutely nothing.
And evolutionary fact and logic demand that things evolve gradually from preceding states.
Right. So if you trace the human brain backward, you get to early hominids.
Yeah.
Then to mammals, then to reptiles, fish, simple multicellular organisms, and eventually all the way down to single-celled amoebas.
So the question is, where exactly on that line does the steam whistle of consciousness just magically appear?
Right. Does a mouse have a within? Does a fruit fly? Does a single-celled organism have interiority?
It's a spectrum, right?
Yeah.
And to avoid this illogical magic trick of consciousness appearing from a vacuum, Teilhard makes his absolute most controversial move.
Here's where it gets really interesting.
He argues we must push it all the way down.
All the way down.
We must accept a state of pre-life or pre-consciousness inherent in all matter.
Even a grain of sand.
Even a grain of sand, even a single electron. Underneath the mechanical layer of physics, there is an incredibly attenuated, utterly rudimentary psychic layer.
Wait. I have to pause here.
Oh.
Because my brain is screaming at the absurdity of a conscious rock.
I know. It sounds wild.
You're telling me an atom has a mind? That a carbon atom is sitting there thinking about its place in the universe? That sounds like ancient animism, not hard science.
It's a very common reaction, but it's crucial to understand he is not saying an atom has a personality or thinks thoughts or writes poetry.
Okay, good. That would be a bit much.
Yeah. Consciousness at the atomic level is almost a misleading word because we heavily associate it with human thought. He prefers terms like pre-life or a microscopic quantum of spontaneity.
A quantum of spontaneity.
Right. It has the absolute lowest possible baseline of interiority. Look at biological examples further down the chain before we even get to atoms.
Okay, give me an example.
Take a slime mold. Physarum polycephalum.
A slime mold.
Yes. It has no brain, no central nervous system. It is literally a giant single-celled amoeba.
Just a blob of biology.
So just a blob. Yet if you put it in a maze with food at the end, it will flawlessly solve the maze, finding the absolute shortest possible route.
Really? Without a brain?
Without a brain. It anticipates changes in its environment. It shows a rudimentary choice. It demonstrates an interior dimension, a reaction to stimuli that isn't just purely Newtonian billiards.
Wow.
And Teilhard argues that this interiority, this within, scales down infinitely, just like the physical plurality scales down. An atom possesses an infinitely small, rudimentary interior spontaneity.
Okay, but even if I accept that, even if every particle has a tiny, microscopic spark of pre-life or within, we still have a massive gap to cross.
It's a huge gap.
How on earth does the universe get from the inert, cold dust of the early cosmos to the teeming, vibrant, highly conscious life we see today? I mean, if an atom is mostly just mechanics with a tiny drop of spontaneity, how do we get to a human brain?
The answer is the engine that drives his entire cosmology. He calls it complexification.
Complexification.
Yes. Or, as Julian Huxley refers to it in his introductory notes to the text, convergent integration.
Convergent integration, so things coming together.
Exactly. The universe doesn't just expand outward spatially in a vacuum. It also folds inward structurally on itself.
Folds inward. Okay.
Over immense periods of geologic and cosmic time, we see a distinct, irreversible trend. Subatomic particles group together to form atoms. Atoms bond to form inorganic molecules. Inorganic molecules group together to form massive organic megamolecules.
It builds up.
At every single step, the physical structure on the without becomes more elaborate, more synthesized, more complex.
Okay, let me make sure I've got this. The vital law of Teilhard's hyperphysics is that the structural complexity of the outside dictates the psychic intensity of the inside.
You've got it perfectly.
The richer and better organized the physical structure on the without, the more highly developed the consciousness on the within. You cannot get high consciousness without highly organized complex matter.
Right. Think of a stellar nebula. Imagine a vast, diffuse cloud of cold space dust, light years across.
Just drifting out there.
It is largely inert, highly plural, but fundamentally unified by weak gravity. Gravity, an intrinsic property of the dust itself, starts pulling it inward.
So it starts to clump together.
As it collapses, it folds in on itself. It gets smaller, incredibly dense, and the internal friction creates massive heat until it literally ignites into a star.
Oh, wow.
The universe, in Teilhard's view, is biologically and psychically collapsing inward on itself in the same way. As matter groups and complexifies, it generates the heat of consciousness.
That structural folding creates what Huxley calls tension. It's like, imagine taking a massive flat sheet of metal, diffuse, cold, taking up huge amounts of space.
Okay, I'm picturing it.
Now, a cosmic blacksmith starts folding it over and over, hammering it into a tight, incredibly dense, glowing core.
Oh, that's a great visual.
That folding is complexification. The physical space it takes up gets smaller, but the internal heat, the tension or consciousness, skyrockets.
Exactly. And to understand how this physical folding actually dials up the interior consciousness, we have to look at how Teilhard divides the concept of energy itself.
He divides energy.
Yeah. He theorizes there are two intertwined forms of energy operating simultaneously: tangential energy and radial energy.
Tangential and radial. Okay, let's break those down.
So tangential energy is physical energy. It is the energy that powers the without. It links a given element with all others of the same order.
Like atomic bonds.
Exactly.
Okay.
It's the strong and weak nuclear forces binding protons and neutrons. It's the covalent chemical bonds holding a water molecule together. It's the energy physicists measure in a laboratory.
Got it. Tangential is the structural glue. What about radial?
Radial energy, on the other hand, is psychical energy.
Psychical energy.
It is the energy that powers the within. It is the force that draws the element towards ever greater complexity and forward into the future. It is the energy of interiorization.
So the gravitational collapse of the nebula, the physical bonding of the atoms, that's all tangential energy at work, organizing the external structure.
Yes.
But the radial energy is the emergent interior state that arises because of that physical organization.
Precisely. And they do not have a simple mathematical conversion rate, like converting mass to energy in standard physics.
So you can't just say like 10 units of tangential equals 1 unit of radial.
No, not at all. Teilhard notes that only a minute fraction of physical tangential energy is used up in the highest exercise of spiritual radial energy.
So it's super efficient.
Incredibly. The physical calories burned by a human brain composing a grand symphony are negligible compared to, say, the energy of a lightning strike.
Oh, right.
But the radial energy, the interior consciousness of that composer, is astronomically higher than the lightning strike.
Yet they're absolutely dependent on each other.
Completely. A richer, more complex physical structure, fueled and maintained by tangential energy, provides the necessary housing and the necessary tension for a higher concentration of radial energy.
This relentless engine of complexification, this steady, laborious process of folding matter into increasingly complex molecules, it really sets the stage for what Teilhard identifies as the greatest crisis and metamorphosis in the history of the Earth.
The big leap.
The transit to life, the appearance of the first cell.
Right. And to grasp this transition, we have to visualize the physical state of the Hadean and Archean Earth.
Take us there. What does it look like?
We are looking at a cooling globe,
Okay.
covered in warm, shoreless oceans.
Just water everywhere.
Everywhere. And these early oceans are a thick, heavy, highly active liquid environment, absolutely teeming with hyper-complex megamolecules.
Like a primordial soup.
Exactly. Carbon chain molecules that have been folding, bonding, and complexifying, driven by tangential energy for millions and millions of years.
But it's not life yet.
No, it's highly complex chemistry.
It is the absolute peak of pre-life.
Yes.
The tangential energy has organized these molecules to the absolute geometric limit of their structural capacity. Because, if you keep adding atoms to a molecule indefinitely, eventually the chemical bonds just can't hold it together.
The physics fail.
Right? The structure becomes unstable. It collapses under its own weight. So how does this soup of megamolecules actually cross the threshold into biology?
Well, Teilhard emphasizes that the transit to life was not just a smooth, continuous chemical reaction.
It wasn't a fade-in.
No. It wasn't just a megamolecule getting slightly bigger and suddenly we call it alive. It was a jump.
A jump.
A radical change of state. An unparalleled moment of germination. Look at a pot of boiling water.
Okay.
As you add heat, the temperature rises steadily. 97 degrees, 98 degrees, 99 degrees.
It's still liquid water.
Exactly. But at 100 degrees Celsius, it doesn't just get slightly hotter. It hits a critical physical threshold and changes state entirely.
Right. The molecular structure breaks its liquid bonds, and it becomes a gas, steam.
It is a phase transition.
Oh, man. So what does this all mean for life? You're saying the complexity of these megamolecules hit a biological boiling point.
That's exactly it, a phase transition of complexity.
The structure could no longer simply expand physically, so it reorganized fundamentally. The first cell appeared. But how is a cell fundamentally different from a megamolecule? Like, if I look at them under a hypothetical supermicroscope, what actually changed in the ream without that cause such an explosion in the within?
It comes down to a concept he calls centeredness.
Centeredness.
A megamolecule, no matter how ridiculously large or complex, is essentially an irregular surface. It is a sprawling chain of reactions.
Okay.
But when it crosses the threshold into a living cell, that physical structure closes in on itself in a completely novel way.
It creates a boundary.
Yes, it creates a semi-permeable membrane. It creates a nucleus. It becomes centered. It establishes a clear, unified boundary between itself and the rest of the universe.
And that centering on the without causes what Teilhard called the internal revolution on the within.
Exactly.
Because it is now structurally centered, it acquires a true dimension of interiority. It goes from the obscure, rudimentary pre-life spontaneity of chemical reactions to being a unified subject.
It has a center of its own.
It has a primitive operating system. The radial energy just leaps to a totally new magnitude.
It's the difference between a highly complex abacus and the very first digital computer.
Oh, that's good.
Both process information through physical laws, sure, but the computer crosses a threshold of architectural complexity where it can actually run software.
It can adapt.
Right. Can store memory, execute conditional logic, and adapt to varying inputs. The cell is the first biological entity with a true operating system. It possesses a true within.
So we have this profound philosophical and biological leap, right? But we also have to understand the staggering physical scale of this event, because the origin of life wasn't just a single, lonely cell floating in a vast, empty ocean getting struck by a lucky bolt of lightning.
Oh, definitely not. That's a huge misconception. Teilhard points out two vital physical characteristics of this cellular revolution: smallness and number.
Smallness and number.
Life began as ultramicroscopic grains of protoplasm. And protoplasm is basically the complex, jelly-like substance that forms the living matter of cells.
Unimaginably small.
Tiny. But their numbers were equally unimaginably vast. For a thickness of some miles, suspended in the warm water, buried in the mud of the shores, These ultra-microscopic grains of protein were strewn thickly, literally like snow, over the entire surface of the Earth.
Protoplasm snow. That image just forces us to adjust our mental scale entirely. The birth of life wasn't an isolated event. It was a planetary event.
Absolutely planetary.
And because of their shared chemical origin in those primordial oceans and their incredible density, this first cellular foam was inherently interconnected.
They had to be.
It wasn't just billions of isolated cells bumping into each other randomly. It acted as a diffuse superorganism.
What's fascinating here is if you think of a fungal mycelial network in a forest today.
Oh yeah, mycelium.
To the naked eye, a mushroom looks like an isolated organism just popping out of the dirt. But underground, it is connected to a vast, sprawling web of microscopic threads that share nutrients, send chemical distress signals, and act as a highly unified collective.
They talk to each other.
They do. And this first cellular layer on the early Earth functions similarly. A massive network of chemical influences and exchanges made it biologically cohesive from the very beginning.
It was a new envelope being wrapped around the planet.
Yes.
And once this living film, the superorganism, was established, it was like a biological fire being lit.
It caught quickly.
It began to expand, to consume the pre-living matter around it, and to fundamentally alter the chemistry of the Earth itself. Which brings us to the next massive evolutionary phase, the biosphere and the elemental movements of life.
Right, because having crossed the threshold from chemistry to biology, this new cellular life faces a really serious physical problem.
It hit a wall.
It did. It has an inherent explosive need to expand, driven by that radial energy we talked about. But remember the geometric limit of the megamolecules?
They get too big and fall apart.
The exact same physical laws apply to the cell. As a cell consumes nutrients and grows, its volume increases faster than its surface area.
Oh, the square cube law.
Exactly. Eventually, its membrane just cannot sustain the internal mass. It becomes physically unstable. It threatens to literally crumble under its own weight.
So how does life, which is absolutely mandated by the engine of complexification to continually grow and expand, how does it survive this physical limitation?
It has to improvise.
It doesn't just stagnate in a stable, tiny form. It discovers the most profound mechanical solution in evolutionary history: reproduction.
Yes, reproduction. And we usually think of reproduction merely as making a copy, a biological urge to just keep the species going.
Passing on the genes.
Right. But structurally, mechanically, it is a brilliant engineering solution. It is a mechanism to multiply without crumbling.
Without crumbling.
When a living cell reaches its maximum stable volume, instead of falling apart into dead chemistry, it divides.
It splits.
It splits its genetic material and its protoplasm into two. It rejuvenates itself. Life at first seems to have reproduced itself only in self-defense against the physical laws of mass and geometry, but this mere defense mechanism became the absolute engine for planetary conquest.
Because once you introduce the principle of geometric progression into the universe, the sheer mathematical force of it is terrifying.
It's exponential.
Teilhard uses the example of an infusorian. Think of the microscopic paramecium darting around in pond water. If there were no limits, no predators, no lack of food, no spatial constraints, a single paramecium dividing exponentially could, in just a few generations, generate enough mass to cover the entire surface of the Earth.
The numbers get huge instantly.
Life acts as an irresistible, devouring conflagration.
Yeah.
It doesn't just exist, it explodes outward.
But if life merely multiplied as perfect, identical copies, it would just be a rapidly expanding blob of identical protoplasm, right?
It would just be a giant gray goo.
It would be highly plural, but it wouldn't be complexifying.
The engine would stall.
Exactly. So this rapid multiplication forces the next elemental movement: renovation.
Elevation.
Reproduction is slightly imperfect. Mutation occurs. Furthermore, as these newly divided cells multiply and spread across the globe, they encounter drastically different environments.
Right, the Earth isn't uniform.
A cell pushed into deep, cold, high-pressure water faces entirely different physical pressures than a cell stuck in a shallow, highly saline tidal pool.
So the environment acts as an external hammer, basically forcing the internal radial energy to adapt.
It forces innovation.
The elemental ripple of life doesn't just spread outwards in a monotonous, expanding circle. It diffracts.
Diffracts, yes.
It's like a beam of white light hitting a glass prism and splitting into a spectrum of colors. Life diffracts into a million different forms to survive the varying pressures of the Earth.
It branches out.
It takes on new appearances, new biological architectures, new directions. This is the root of the evolutionary tree of life.
And if we connect this to the bigger picture, this devouring, diffracting conflagration of life ultimately changes the literal physical architecture of the planet.
It rewrites the Earth.
It does. Before the transit to life, the Earth's history was defined purely by geogenesis.
The evolution of the physical Earth.
Right. The cooling of the molten crust, the venting of gases to form an atmosphere, the condensation of water to form the early ocean.
Just rocks and gas.
But with the explosion of cellular life, geogenesis shifted its primary axis. It literally became biogenesis.
So life didn't just populate the Earth. It created a brand new physical layer entirely around the globe. The biosphere.
Exactly. Just as the Earth has a lithosphere of solid rock and a hydrosphere of liquid water and an atmosphere of swirling gases.
It generated a biosphere of living, breathing tissue.
Yes. It is a single, vibrating, interconnected film of complexified matter that completely covers the globe.
I love that. You know, next time you're looking out of an airplane window at 30,000 feet, try to adjust your vision. Look past the individual trees, the patches of ocean, the herds of animals, or the sprawling cities.
See the whole.
Try to see the biosphere exactly as Teilhard saw it. See it as a single, unbroken, vibrating film of hypercomplex matter that the Earth literally sweat out of its own atomic structure over billions of years.
Sweat out. That's a powerful way to frame it.
It's not just an infection sitting on top of the Earth. It is an intrinsic layer of the Earth itself.
And by tracing this entire process from the elemental plurality of atomic matter, driven by tangential energy, to physically unify and complexify.
Which generates the radial energy of interiority.
Exactly. And crossing the boiling point into cellular life and exponentially multiplying to form the biosphere, Teilhard finally achieves his hyperphysics.
He pulls it all together.
He demands that we stop viewing matter and spirit or physics and biology as enemies.
Because they aren't enemies. They aren't even separate disciplines in the grand scheme of cosmogenesis.
Oh, they're the same thing.
They are the exact same cosmic stuff, just viewed from the outside and the inside, the without and the within.
The dual aspect.
The unimaginably intricate physical complexity of the biosphere on the outside is exactly matched by the roaring, expanding consciousness on the inside.
So true. The universe is not a dead machine ticking down to heat death. It is a continuous, laborious process of interiorization and awakening.
It is such a stunning synthesis. It restores a sense of profound meaning and direction to the cosmos. And it does it without sacrificing a single ounce of rigorous empirical scientific truth.
It takes the hard reality of evolutionary biology and basically reveals its hidden architecture.
Well, we've covered massive ground today. We started with the cold, particulate dust of the early cosmos.
The pure plurality.
We watched the relentless, intrinsic engine of complexification fold matter in on itself, much like gravity igniting a star.
Generating that tension.
We saw it concentrate its hidden within until the physical geometry could no longer hold, forcing a phase transition of the boiling oceans and bursting forth as the centered, spontaneous reality of the very first cell.
The huge jump.
And we watched that cellular fire spread, diffracting and multiplying to evade physical collapse until it wrapped the entire globe in a living biosphere. But I want to leave you with one final provocative thought.
Let's hear it.
We've traced the folding of matter all the way up to this planetary layer of biological life.
Yeah.
But remember Teilhard's law of complexification. The universe doesn't stop folding.
No, it keeps going.
The engine doesn't shut off just because we reach biology. It keeps generating more internal heat, more within.
The tension increases.
So ask yourself this. If a planetary layer of simple cells, chemically interacting with each other, eventually created the vast, complex web of the biosphere, what happens next?
Oh, that's the big question.
What happens when billions of highly complex, self-reflecting human brains start folding in on themselves? What happens when we start connecting our individual nodes of consciousness across the globe through the internet, through culture, economics, and instantaneous communication?
A new layer.
Are we currently, right now, sweating out a brand new invisible layer of the Earth? A sphere not of rock or water or even biology, but a living, breathing sphere of collective human thought.
It's incredible to think about.
Keep pondering that the next time you pick up a simple rock or watch a drop of water fall. Thank you for joining us on this deep dive. Keep questioning the without and never stop looking for the within.